Okay, everyone, we're going to get started. Hopefully, you can see a slideshow. All right. So, welcome back, everyone. Hopefully, you had a really good week. And today, we're going to be continuing the stuff we learned last week about analytic geometry. Last week was an introduction. Oh, there's Devin. Quickly add you to attendance. So, last week we did an introduction to analytic geometry. Today, we're going to learn a couple more concepts in this topic because it's like a really broad one. I might have to teach it. Maybe I'll teach it again next week, but we'll see. Yeah. There's a lot of stuff to cover in this topic, but I guess we'll just only do like the important ones for this term. So let's continue. So first thing we're going to focus on is points, like points in a Cartesian plane. So we're going to look at some like formulas and concepts for points. So let's go to the first slide. All right, so the first thing we're going to look at is how to find the distance between 2 points. And yeah, so say you have this, say you have 2 points. You have one that's A and one B, and you want to figure out how to like calculate the distance between them, right? I'll give you guys like a couple seconds to think about how you'd approach that, right? So just think about that, how you would calculate the distance between these 2 points. And say you're given the coordinates as well. Okay. So hopefully you had some time to think about it. Some of you probably already know the formula already, but let's move on to the next slide. So this is how you actually find the distance between these 2 points. First thing you do is you connect the 2 points, so we connect A and B, with a straight line. So let's look at the diagram over here. So they connected it with this line segment called C. And the next thing you do is you draw out the vertical and horizontal components of the line. So the rise and run. Nope, we have the principal joining. 金老师好. Okay. So what I mean by connecting the vertical and horizontal components. So look at the left diagram right here. Let me get a pointer out so it's more clear. So you can see that A. So they drew out this horizontal component called A, and they also drew out this vertical component called B right here. So B is the rise, and then A is called the run. But these aren't too important. Just realize that you'll realize that you can use Pythagorean theorem to calculate what the value of C is, right? So you have A squared plus B squared is equal to C squared. And so that means C would just be equal to the square root of A squared plus B squared. And let's look at in terms of like the actual coordinates, right? They didn't connect the line here, but just pretend like there's a hypotenuse for this triangle. And here's a right angle right here. So you see that the rise or the vertical component is the difference between the y coordinates, so ya minus yb. And then the horizontal component, so from here to here, is the difference between the x coordinates, so xa subtract xb. So and if you do the Pythagorean theorem on that, you get, so say you call the line segment here C, you get like in brackets xa minus xb all that squared, plus in brackets ya minus yb all that squared is equal to c squared. Actually, let me show that on a whiteboard so it's more clear, you guys. Okay. Right, so here's the whiteboard. Yeah, and I decided to ditch out Google. I think it was out Google Canvas. Yeah, this is called the A board, and I believe it has like more functions, a bit more functionality. It's better to use because you can draw shapes and all that kind of stuff. But we won't use that for now. Okay, so what was I doing? So we had this. Start a graph. So this was XA, or this is XB, sorry. This is YB. Oh, someone joined. Selena. All right. Add you to attendance. Basically full class. Nice. Okay. So this is XBYB. This is XAYA. Let's label it somewhere else. All right, so say we drew a line. So that's the distance between 2 points. We can call that C. Oh, someone else is joining. Is it Chenglo? All right, I think now we're full class. Okay, hello Chenglo. All right, so we're just looking at how to calculate the distance between 2 points on a Cartesian plane. So that's what we're doing right now. So we have this, the distance is called C. We also have the vertical components and vertical and horizontal components. So vertical one was, so let's label it here. This is just difference between the y coordinates. And we also have a horizontal component. It's just difference between the x coordinates. E minus xa. So remember, vertical and horizontal components form a 90 degree angle. Sorry, I can't speak. Or a right angle right there. And you see that this is a right triangle. Right? So that means you can use Pythagorean theorem here. And so what the equation will look like is you have this squared plus this squared is equal to c squared. So let's write that down. So xb minus xa, all that squared, plus yb, whoops, did not mean to write x, yb minus ya squared equals c squared. Just like that. Because this squared plus this squared is equal to this squared because of Pythagorean theorem. Makes sense. And you can always switch the order of these guys. You can switch the order of the xa and xb around. It doesn't matter because once you square it, the negatives will cancel out. And so if you just want c by itself, you just take the square root of everything. And that's how you calculate the distance between 2 points. So you get this equation. xb minus xa squared plus yb minus ya squared. Right, send that square root. So this would be your final formula if you want to calculate distance between 2 points. If the 2 points are xb, yb, and then xa, ya. So that's the formula right there. I'll also show it in the slides as well. So let's go back to the slideshow. All right, does anyone have any questions about this though? Like how I proved this distance between 2 points formula? Any questions? Okay, I'm going to assume there are no questions. So this is what the final formula looks like. This is between 2 points. Say we have x1, y1, x2, y2. It's just the square root of, and then we have x2 minus x1, all that squared, plus, and in our brackets, y2 minus y1, all that squared. Take square root of that, you get your distance, which we call it d. I use the same diagram over here, just to give you guys a clear idea of what it looks like. Okay. Are there any questions about this formula though? Hopefully it's pretty straightforward. Right. If there are no questions, let's look at a problem. It's fairly straightforward. So find the distance, find the distance between these 2 points. We have 4, 7 and 3, 15. Right? I'll give you guys a minute to solve that. You just substitute those points to the equation. It's very simple. So root 65. That looks correct. I think it's root 65. Sounds good. Let's just do it on a whiteboard. Just be double sure. So, whoops, trying to write something. Oh, okay. No, that's text. I'm trying to draw some. Okay, let's do d. Let's call our distance d. So remember that formula, we take the difference of the x coordinates. So we have 4 and 7. Sorry. So that's our first point, 4 comma 7, and second point, 3 comma 15. So let's take the second coordinates and subtract them from first coordinates. So 3 minus 4 squared plus 15 minus 7 squared. What do we get from that? This is just negative 1 squared plus 15 minus 7 gives you 8 squared. So then we just simplify that even further. It's just 1 plus 64. And you get square root 65. Just as Aiden said, I believe. Yeah, Aiden said that. Nice. There you go. Right, so this is the distance between those 2 points, right? Any questions about this? If there are no questions, go back to slideshow. Okay, let's move on to our next concept. Now we're going to look at the midpoint between 2 points. So you guys don't know what the midpoint is. It's fairly straightforward. It's just the halfway point between 2 points. So say look at the diagram here. You have a point A, and you also have a point B. And so the midpoint would just be around here. And how would you calculate the coordinates of this midpoint though? So we know that it's halfway between point A and point B. That means that we have to take the sum of their x coordinates and divide that by 2, and also have to take the sum of the y coordinates and divide by 2. So think of it as like it's the midway x, the midpoint. It has its x coordinate is the middle x coordinate between like the x coordinate of B and the x coordinate of A. And same thing for the y coordinate. Its y coordinate is halfway in between the y coordinates of A and B. And that's how you get this formula. Here we use x1, x2, actually. So this is the midpoint formula. You have, for the x coordinate, you have to sum the x coordinates and divide that by 2. And same thing for the y, you add up the y's and divide that by 2. All right. Are there any questions about this formula? This one's very straightforward. You've done midpoints before? All right, so I guess this is a review for your Aiden. Okay, if there are no questions, let's try a problem. Okay, find the midpoint between these 2 points. We have negative 3 comma 0. Negative 0.5. And second point is 4 comma 1.5. Right. Give you guys a minute to solve that. And yeah, if you have an answer, just type in the chat or... Damn, that was quick, Aiden. Yeah, I guess 1 minute was too long. 0.5 and 0.5 seems correct. Very nice. That was really quick. I'll give the other guys a bit of time to solve this. Just gotta give you guys a couple more seconds. So take it up on the board too. All right, so let's take it up. Okay, let's use a whiteboard. So let's write down the midpoint formula again. Y1 plus Y2, divide that by 2. There you go. So our first point was -3 and -0.5. Sorry, let's look at the axis first. So we have -3 and 4. So -3 plus 4, divide that by 2. It doesn't matter which one you use as x1 and x2. We always put 4 first and -3 at the end. And then we have -0.5 plus 1.5. And that divided by 2. Right. So for both these, you should get one. Just 1/2. 1/2. And you could always just rewrite this as a decimal because the y coordinates here are also decimals, but it doesn't really matter. You always leave it like 1/2 and 1/2. But I guess we're just going to be a bit more consistent. We're just going to be consistent with the other points. Just going to write it as a decimal. So it's just 0.5 comma 0.5. All right, there you go. So that's the midpoint. Are there any questions about this problem? All right, give me a second, guys. All right, I think I'm good. Okay, let's go back to the slideshow. There you go. So now we just finished looking at points. Now let's look at circles. And some of the formulas we used in the points for what we looked before for points will apply in these circle formulas as well. So let's take a look. First, let's look at how we get the equation of a circle. So let's think about this one. How can we find the equation of a circle with center 0, 0, 0, comma 0 is the center of a circle, and it has a radius of 5. So how do you find the equation of that? Give you guys a few seconds to think about that, how you would do that. So remember in the circle that the center point is always equidistant, or it's always the same distance from the circumference of the circle. And this distance is the radius. Now let's just review. Just equation of this circle. So how would you figure that out? So you know how lines have like an equation of like y is equal to mx plus b. We also learned that quadratic equations have like an equation of y is equal to ax squared plus bx plus c. We want to figure out something similar for circles. And it's very different. So, let's actually see how we solve this. Right. So first thing we do is that we label any point x comma y on the circle's circumference. Right. So say in this diagram we had x comma y over here. And the next thing you do is just draw a line from the center to that point x comma y. And that distance is just the radius. And then we're going to do a similar thing we did before to like calculate the distance between two lines. We would draw the vertical components and the horizontal components as well for this x comma y point. So we have the horizontal component, which is x, and the vertical component, which is y. And just draw those out. And basically from here, we can just use the distance between 2 points formula to find our equation. And I'll show you guys how to actually get it for this specific circle. Let's go back to the whiteboard. Let's make some space. All right. See if I can draw straight lines from this. Just give me a second. Still trying to get used to this software. Right. Let's try it out. All right, that looks really good. Let's draw a circle as well. See how we start out. Okay. Let's make it a bit bigger. Right, that looks like an ellipse, but whatever. What's more important is that, so draw a point x comma y. Say this was the point. Let's use that sorry, I'm gonna say that the radius is 5, and then its center is at 0, 0, so the origin. Let's also draw out the vertical horizontal components. I know the horizontal one's it's not a bit clear, but because it's lying on the x-axis, but you guys should understand. So that distance would be x, and then this vertical distance would be y. All right. So this looks exactly like the diagram we had for the distance between 2 points formula. So let's use that. So if you remember, we have, so 5 would be that the distance we're trying to calculate between x comma y and the origin, right? Remember that this point can be anywhere as well. So from over here, this would also be 5. Say if it was like over here, this distance would also be 5. Right, so it doesn't matter where we choose x comma y to be. It can be anywhere on the circle's circumference, that is. So let's use that formula. So distance between 2 points. So we have 5 is equal to, in brackets, we take the difference between the x coordinates. It's just x. Let's also take the difference between the y coordinates. And that's just y, because y is minus 0 is just y. So we have 5 is equal to x squared plus y squared. Okay? And now what we can do is we square both sides. We always want to get rid of a square root whenever we can. So let's square both sides. Now let's write the x squared and y squared on the left side this time. So x squared plus y squared is equal to 25. And for an equation of a circle, this is the exact formula that we want, actually. We want to keep the x squareds and the y squareds on the same side, and we keep the constants on the right side. Right, so this would be the equation for this specific circle. And let's look at a general equation for any circle as well. So let's go back to the tab. So that's kind of how you prove, like how you would get, or like how you'd get the equation of any circle. But let's look at it in more detail. So this equation, it looks very different from like a line, equation of a line, or an equation of like a polynomial or a quadratic, right? So in this case, you have all the x's and all the y's on the left side, and we have a constant on the right side. So the equation looks like this. So you have in brackets x minus a squared plus, in our brackets, we have y minus b, all that squared. And that's equal to r squared. So what do some of these variables mean though? Let's take a look. We have a and b. So we put those in coordinate form. So we have a comma b. That would give us the center of the circle, right? And we also have this variable r. R is actually the radius of the circle. So if we look back at that equation, so x squared plus y squared is equal to 25. We had r squared is equal to 25 on whatever's on the right side, which is 25. And r, so if you take a square root of 25, you would get 5. And 5 was the radius of that circle, if you remember. And if we solve for a comma b, that would just be 0 comma 0 for that circle. But yeah, let's look at another example on Desmos. Let's make it more clear for you guys. Let's look at Desmos. If we can draw a circle for you guys. All right, there you go. All right, we have this circle right here. So we have x minus 1 squared plus y minus 1 squared is equal to 4. So that's the equation of this circle. I also drew out this point 1 comma 1. And you notice that 1 comma 1 is the center of the circle. So you see it's like the same distance from the circumference. And you can see from like the equation itself, so you have 1 from, you have the 1 here, and you also have 1 from here. So that gives you the center of the circle. And 4 is your r squared. So to the square root of that, you get r is equal to 2. And so r equal to 2 would be your radius of the circle. And it makes sense. So if you say calculate distance between 1 comma 1 and 1 comma negative 1, that distance should be 2. And same thing for any other point on the circle. So we have that. That should also be 2. Right. Are there any questions about this? So this equation of a circle. Just remember this general formula. Any questions about this? Yeah, radius is 2, Aiden. Yeah, remember, don't mistake the radius for the diameter. Remember, diameter is like, you have, diameter is twice the length of the radius. And it goes through the entire circle. Radius only touches one end of the circle. Right, so hopefully you got this equation memorized. Well, you don't have to necessarily memorize it, just understand, like, I think these are most important points. You have AB is the center of a circle and R is the radius. And just remember like where those are in the equation. Okay, what's our problem? Okay, so here's the problem we're going to solve. So find the equation of a circle with center 2 comma negative 1 and a radius of 10. Right, I'll give you guys a minute to solve that, or just a couple of seconds. It shouldn't take too long. Yeah, if you have an answer, just type it in chat or unmute yourself. X minus 4 plus y minus 1. That doesn't look correct, Aiden. Here, I'll give you guys a look again. So this is what it should look like. The equation. So x minus a squared plus y minus b squared is equal to r squared. So r is the radius, a, b form your coordinates for the center of the circle. All right. So try it again. I think Bob got it. Let's see. X minus 2 squared plus y plus 1 squared is equal to 100. Yep, that's correct. Let's just do it really quickly on the whiteboard. So we have center 2 comma negative 1 and a radius of 10. So just I'll write down the equation of a circle again. Just get you guys familiar with it. So this is x minus a squared plus, and another brackets, y minus b squared. That's equal to r squared. Let's go down a little bit. All right. So this would be a would be equal to 2. This would be b is equal to negative 1. And r is, you just substitute here. So x minus 2 squared plus y minus negative 1 squared. And that's equal to 10 squared. Substitute r equal 10 into here. And you just simplify this. Right. So this would just be plus 1 because 2 negatives cancel out. And 10 squared gives you 100. All right. And you just leave the equation of the circle as is, just like this. Right? So x minus 2 squared plus y plus 1 squared is equal to 100 is your equation of this circle. Any questions about this? All right, if there are no questions, let's move on to the next concept. So the equation that we looked before, so this equation right here, x minus a squared plus y minus b squared is equal to r squared. This is actually the standard form for an equation of a circle, right? So that's one form. And we can also have an expanded form for an equation of a circle, and it looks like this. You have x squared plus y squared. So the x squared and the y squared have to look like this. There's no coefficients and there's no negatives. They have to be x squared plus y squared, right? And then after that, you have some plus ax plus by and then plus some constant c, and all that's equal to 0. So unlike standard form, we don't have brackets anymore, and we also have the constant term on the left side, which is, so constant term is c. So a, b, and c, they can be anything. So these values don't really matter. So that's expanded form, and this was standard form. So if you want to convert between these two forms, so let's look at standard form to expanded form. This is fairly straightforward. You just expand the brackets. So you expand whatever's in here, x minus a squared, and you also expand y minus b squared. So expand those, and then you move all the terms to the left side of the equation. So once you get r squared, you also have to move that to the left, right? But then let's look at how we get from expanded form to standard form. So if you guys remember last week, we learned about this technique called completing the square. So if we want to convert like a polynomial function, or sorry, so if you want to convert like an x squared function to a perfect square. So that's what completing the square was, if you guys don't remember. We'll go over example about that right here. But so basically, if you want to convert from expanded form back to standard form, you want to complete the square, and then you want to move all of your constants outside, and you want to move them all to the other side of the equation. So you see r squared is over here. So let's look at an example of that. So here we have this equation in expanded form. We have x squared plus y squared minus 2x plus 4y minus 10. All that's equal to 0. And so we want to complete the square. So what you want to do is put brackets around the x term. So we have x squared minus 2x. So I actually did this in like 2 steps. So remember that if you want to convert something into perfect square, you have to add a constant term to that. And then you also have to subtract the constant term just to make sure like the equation still equals out, if that makes sense. And then you have in your second term, you can combine the y terms. So you have y squared plus 4y. And you also have plus 4 minus 4. So that will give you your perfect. So y squared plus 4y plus 4. This will give you your perfect square. Similar thing for x. You have x squared minus 2x plus 1. That gives you your perfect square. And basically get rid of the negative 1s and negative 4s outside the brackets. And you have minus 10. We keep that outside. We don't do anything with it. And all that's equal to 0. Right? And so if we convert those to perfect squares now, we have in brackets, we have x minus 1 squared plus, and under brackets, we have y plus 2 squared. Right? And then we take the constant terms out. So we have minus 1, minus 4, minus 10. All that's equal to 0. And I hate how there's a menu right here. That's kind of blocking whatever's down there. But let's let it disappear for a sec. All right. So you see in the bottom there, that would be our final answer for a standard form. So we have x minus 1 squared plus y plus 2 squared is equal to 15. So we have minus 1, minus 4, minus 10. That gave you negative 15. And then we move that to the right side. So we add 15 both sides. And so your r squared would then be equal to 15. So that's your standard form right there below. Yep, see, if I move my mouse down here, the menu pops up. It's kind of annoying. Can't really fix that. But it is what it is, right? Are there any questions about this? Hopefully you guys remember how to complete the square. Okay, if there are no questions, I think you have a problem coming up. Yep, here we go. All right, so let's look at this problem. So find the equation in standard form. So remember, we want brackets in the equation. So we want to find the equation of standard form for this equation. X squared plus y squared plus 16x minus 10y plus 100 is equal to 0. So this is expanded form. We want to convert that to standard form. And next question, does this equation represent a valid circle? So you'll figure out what this means once you actually get your equation. So I'll give you guys a minute to maybe solve this or think about it. Probably won't get it in time, but just take some time to think about it, how you solve this. Yeah. And if you guys have an answer for the equation already, just type in the chat. I think saying it out loud would make it a bit confusing, so just type your answer in the chat if you can. And if you actually get the equation yet or no? Not yet. That's fine. I think I'm just gonna take this up with you guys. We're a bit short on time. I got a couple more questions later to solve. So yeah. So let's write down the equation again. So we have x squared plus y squared plus 16x minus 10y and plus 100. All right, so let's put the x terms in their own brackets. Right. And let's also do the same thing for the y terms. Right, so now we want to complete the square, right, for each of these bracket terms. So we want to add number and also subtract a number. So we want to add something, and we also subtract that same thing. Same thing for the y. Let's move this to the right a little bit. So we have y squared minus 10y plus something, and also minus that same thing. And then outside we have plus 100 is equal to 0. All right, and just for reference, I'm going to put down this formula. So we have a minus b squared. We'll just do a plus b squared. So this is what like a perfect square would look like for a quadratic formula. Oh, sorry, a quadratic expression. So this would be a squared plus 2ab plus b squared. and this were minus, this sign will just be a minus. Then. So this is a minus b squared. You have a squared minus 2ab plus b squared. So let's look at the first. Let's look at the first bracket. So can someone tell me what to put in these blanks right here? Does anyone know what to put in there? So for these two brackets. So we have a. This would be a. A would be x. So this is a. Or this whole thing is 2ab. And this will get you your b squared. And this will also be your b squared. Right, for this as well. Would it be positive 64 and negative 64? That's correct. Yep. So why is that? So let's look at it. So we have a is equal to x, right? And so we have 2ab, and we just substitute a for x there, we just get 2xb. So if we want to get 2xb is equal to 16x. If we want to get those equal to each other, that means b would have to be equal to 8. So we have 2x times 8, that would give you 16x, right? And so if b is 8, then b squared would give you 64. And we have to add and subtract that. So that's how you complete the square for this side. Now let's look at the next one. So the y terms. And someone tell me what to put in these blanks. What should I put in these blanks right here? Chenglong says 25. 25 is correct. So let's look at that. So we have, this is 2ab, so that will equal to 2yb. So we have 2yb is equal to negative 10y. Drawing with a mouse is pretty difficult, just to let you guys know. But okay, so we have 2yb is equal to negative 10y. We want b, so we just divide both sides by 2y, and that would just give us b is equal to negative 5. You can substitute it back into this just to make sure. So 2 times negative 5 would give you negative 10. And you have your y's, so that makes sense. And so we take b squared, so negative 5 squared, the negatives would cancel out, and that would just give you 25. So this would be 25, and also we have to subtract 25. We have to make sure that this part, so this, like this whole thing, this line is equal to the previous line as well. So that's why we add and subtract these numbers. All right. So now let's actually complete the square. So let's convert the perfect squares into brackets. So we have, for the first one, we have x minus 8 squared. So remember, it's a plus b squared, or sorry, yeah, a plus b. So x plus 8 squared, sorry. And then we also have, for the y, we have y minus 5 squared. And we also take these numbers out. So minus 64, minus 25. So we take those out of the brackets, and we also have a plus 100 at the end. All right, I'm just going to simplify this in one step. So minus 64, minus 25, plus 100. Can someone tell me what that is? So what is this part equal to? Yeah, 11. Let's double check. Yeah, it's 11. Okay, so we have x plus 8 squared plus y minus 5 squared plus 11 is equal to 0. And we just move the 11 to the right side of the equation. I'm just going to undo those. And so we just subtract 11 from both sides, so we get this final answer. So we have x plus 8 squared plus y minus 5 squared is equal to negative 11. So that will represent your equation in standard form. But is this a circle? Can someone tell me yes or no? Is this a circle or not? Does this represent like an actual circle, or is there something wrong with it? Someone tell me. Perfect, right. Yeah, yeah. So remember in the equation of a circle, we had our r squared term on the right side. And so we have to, for this equation, we have to equate r squared is equal to negative 11. And there's no solution to r that would give this. So this would give you no solution. It's right like that. No sol or no solution for r. So that means if you don't have a radius, then you can't have a circle. So this would not be a proper circle then. But it's an equation standard form. All right. So that's that problem. Let's move on to the next one. But does anyone have any questions about this though? All right, if there are no questions, let's move on. Okay, let's look at some more problems. Let's look at this one. So prove that the vertices 2, 0, 4, 2, 2, 4, and 0, 2 form a square. I'll give you guys a minute to think about this one. So it's a proof question. There's no like definite answer or anything. We just have to like prove it out. And so just figure out like what process you would use to prove this. So remember in the square that it has 4 right angles, but then also the sine lengths of all 4 sides are equal to each other. So we want to prove those prove those properties. And I think I'm just going to take this up. I'm trying to find some space on my whiteboard. All right, let's do it right here. Okay, so let's label our points again. We have 0, 0. Let's call this A. Let's call our next point B. I believe it was 4, 2. Okay, 4, 2. Oh, A is not 0, 0. My bad. This is 2, 0, not 0, 0. We also have B, 4, 2. Now let's have a point C. That would be the next point, which is 2, 4. And we also have another point. Let's call it B. This would just be 0, 2. All right, perfect. So if you want to draw this out on a graph, that actually be very helpful. So you just want to visualize, like, does it look like a square at all or not? It's good to know. And let's just use circles to represent the points. So say 2, 0 was right here. And you know what? Let's just draw it out. Let's use a marker. So this would be 2, 0. Your 4, 2 would be around here. Around here. And then you have a 2, 4. This would be around here. And you also have 0, 2, which is around here. And so now you can see like how these points form a square. So if you want to draw these out, if you want to connect the dots, they will look like this. So that's what it looked like. And so you have one right angle right here. These would also be right angles. Okay. So now let's actually try to prove this. So we have we have 2 comma 0 and 4 comma 2. Let's find the slope and distance between those 2 points. And we're going to do the same thing for the other pairs of points as well. So we want to find slope of AB. So remember, slope is just difference between your y coordinates, divide that by distance, the difference between your x coordinates. So this would just be 2 over 2. And that just gives you 1, right? Let's look at the distance as well. DAB. Let's call it DAB. And so we have x2 minus x1 squared. So this would be 4 minus 2 squared. We just write it as 2 squared. So just shortcut it out. Because we kind of already did that in our slope formula. So this would correspond to that. So that's your x2 minus x1. And we also have our y2 minus y1. So you have 2 squared plus 2 squared. If you solve for that, you have 4 plus 4, which is just 8. So this would just be square root of 8. We just leave it like that. Now let's also look at BC. So this is B, this is C. So this would just be 4 minus 2. 2 minus 4. So this is 2 over negative 2 this time. So not positive 2, but negative 2. And this would just give you negative 1. There you go. And then if you want a distance, it'll look like this. So you have 2 minus 4 would give you negative 2 squared. And you also have the 4 minus 2. So from here, plus 2 squared. So you realize this is also 4 plus 4, which is 8. So square root of 8. So now we see that these distances are equal. And we also see that this slope, so MAB, is perpendicular to this slope, MBC, because these are negative reciprocals of each other. So if you multiply them together, they have to equal negative 1. And if you multiply 1 by negative 1, then that's obviously negative 1. All right. And we also have to prove the other points too. I know this is a bit tedious, but we have to do that for a proof problem. So this is 2 minus 4. And we also have 0 minus 2. So this is just negative 2 over negative 2. That gives you positive 1. So you see that this slope, MCD, is also perpendicular to this slope, MBC. And it's also parallel to slope MAB. So it's a good thing to know. And then for our distance formula, we have negative 2 squared plus negative 2 squared. And this will also give you square root 8. All right. And we need to, now we have to prove the final pair of points. So we have D and we have A. Those are connected together. I don't see where we have space. Let's do over here. Okay. So now we have slope of, let's just call it AD. So let's look back at our points. We have 2, 0 and 0, 2. So let's take difference. Let's say D is our x2, y2. So this is 2 minus 0. We also have 0 minus 2 on the bottom. So it gives 2 and negative 2. And this is negative 1. So you see this is perpendicular to CD and AB, and it's also parallel to slope BC. So that's what we want for a square. And then just prove the distance. So D of AD. So we have 2 squared plus negative 2 squared. That would also give you distance of square root of 8. All right. So you can see that the line segments, so the lengths of the side lengths of the square are all equal to each other. And also the slopes, you can see that they form right angles with each other. So this forms a right angle of BC. BC also forms a right angle of CD. CD forms a right angle of AD, and AD also forms a right angle of AB. Right, and then that's what we want to prove that these points form a square. Right? Are there any questions about this? Analysis was pretty tedious, but like in a proof problem, you have to be a little bit tedious with your solutions. Right? If there are no questions, I'm going to move on to the next problem. So let's look at this one. So the diameter of a circle has endpoints -5, 0 and -1, 6. Now we want to find the equation of the circle in standard form. So I'll give you guys a few seconds to think about it first. You don't have to solve it right now. Just think about how you approach this, and we'll solve it on the whiteboard. All right, well, let's take a look. Let's get some space. All right, let's draw out the graph. It's always helpful in like these kind of problems to like draw it out visually. Right, so point -5, 0. This would be around here. And we also have point -1, 6. We're just estimating this would be like around here. So this is the diameter of a circle. And to get the equation of a circle, we want the center points and the radius. So let's assume that center point, let's estimate the center point. It's around here. And we also want to find the radius, right? So let's try to find the center point first. So if you notice, the center point is actually the midpoint between these two endpoints, right? So because in a diameter, the center point is like right in the middle of the diameter. And so that means it's the midpoint of it. And so that means they'll have half of the x coordinates and also like one half the sum of the y coordinates. So let's do that. So let's call this let's call it center. Let's call the center C. So I want to find the coordinates of this. So basically what we do is just add the x coordinates and add the y coordinates and divide those by 2. So we have -5 minus 1. So those are the x's. Divide that by 2. And we also have 0 plus 6 for the y. And divide that by 2. Right, so that should give you -6 over 2, which should give you -3. And you have 6 over 2, which would give you +3. There you go. So these are your center coordinates of the circle then. I'll also draw out this circle, because why not? I'm trying to estimate it right here. And no good. That's a little bit better. All right, so this is what the circle would look like, kind of. Now what we want to do is find the length of the radius. So the diameter is always twice the length of the radius. Remember that? So that means that if you want to get the length of the radius, we just divide the length of the diameter by 2. And we can find the length of this diameter by, doing the distance between these 2 points. Find that. So find the distance between these 2 points. So let's do that quickly. Right, so let's find distance. So we have x2 minus x1. So let's do -1 minus -5. All of that squared. And we also have difference between y coordinates. So that's just 6 minus 0. All that squared.